In this video, we're going to go over a couple additional, more thinky type problems, some problems that are a little not standard, and hopefully as you get through them, you'll realize these are pretty cool and not so bad. All right, so just like everything in math, we're going to start off by saying, what are the information are they giving me? They're telling us our goal is to find a second degree polynomial. So we have to go back to the definition of a polynomial, which is some function where we have coefficients times x raised to some value that is a whole number. So positive counting numbers or zero. In the front can be any real number, whether that's a counting number, a square root, something irrational, doesn't matter as long as it's real. So it would look something like this. X to the n minus 1 plus c times x to the n minus 2 plus dot dot dot, so on and so forth. But for us, because they say it's second degree, we know it's a times x to the, not that, second degree, 2, plus b times x to the first plus c. Therefore, because the degree being 2, we know that's as big as it can be. And it has to have some term, or it could potentially have some term with x to the second, x to the first, and then x to the 0. And that, x to 0, and that's all we've got. So, long story short, this is what we're looking at. Now, use the information to find this polynomial. We need to find some value of a, some value of b, some value of c. Well, notice this hopefully is kicking back ideas from college algebra, which was when I need to know three things, when I need an a, b, and a c, I need three pieces of information. I need to be able to build three equations to be able to solve a system. This is going to be solved as a system of equations. So notice, pretty easy to catch on this problem. Sometimes I have to do a little bit more careful reading to find the third piece of information. But what are they telling us? P of 2 is equal to 17. So I know for my original function, if I sub in 2, it should be equal to 17. Okay, cool. So let's just do a little bit of simplification to make this look a little better. And we'd say that's about as good as we can do, right? That's not going to get much cleaner than that. I have nothing else to solve for at this point in time. Right, so our first piece of information was I know P of 2 equals 17. So that's what I subbed in to get this first equation. I said I know P of 2 is equal to 17. Right, that's how we got this equation here. Okay, now our next piece of information, what do we know? P prime of 2 is equal to 18. So we're going to use P prime of 2 is equal to 18 on this next idea. Notice we're completely going from a reset. We're going back to the original polynomial that we started with. P of x is equal to ax squared plus bx plus c. And we're going to say, what do I know? Well, I know the derivative because p prime. So I need to take the derivative of this function. So p prime of x, well, all right, power rules, x squared. So I bring the 2 out to the front. Subtract 1 from the exponent. A is just a constant, right? It's like having a number 4 there, so it's 2 times a. So we leave that alone, right? We're moving on. B times x, well, it's x to the first, so we bring the 1 out to the front. So it leaves us with b times x to the 0. And anything to the 0 is always 1, so we're just left with b. Then last but not least, plus c. Well, c is x times the 0, so the 0 comes out to the front, making the derivative of that 0. All right, so simplified, it leaves us with the derivative being 2ax plus b. Okay, but what do I know? Well, in highlighted here in blue, I know when I plug in 2, when I substitute in 2, this should be equal to 18. So I know the slope is 18, slope of the tangent line is 18 when I substitute in 2. Okay, and let's just do a little bit of cleanup here. 2 times 2 is 4. Okay, so once again, I still have two unknowns. I have an a and a b. Nothing. I mean, I could solve for the b if I wanted to, right? I could solve for b and say, okay, so what? 18 minus 4a is equal to b. Maybe, and then I could use that, a little bit of systems of equations. I could sub that in to here, but it's not going to be super helpful yet because I need three equations. So let's keep moving. All right, I need some other relationship to be able to work the system completely. All right, oh, and what do we see here? Well, okay, our next piece of information is P double prime of 2 is equal to 10. So what do we know? I know from this piece of information that when I have the second derivative and I sub in 2, that should be equal to 10. All right, so here we go. I go back to the original equation and do the derivative. And hopefully you recognize that's right there. So we didn't actually have to go back to the original equation. We have the derivative sitting right there. You can use it. And we're going to go from the derivative to get the second derivative. So the derivative of this, again, x to the first, so that's going to leave us with 2a plus, and then x to the 0, derivative of x to the 0, that would just be 0. So that simplifies just to be 2a. And now we substitute in. We say we know that when we sub in 2 for x, not for a, when we sub in 2 for x, we should be equal to 10. And now we start working backwards. We say, okay, let's solve what we can. Let's solve for what we can and see what we can figure out. Well, the nice thing here, because there was no x's, well, the math was simple, just 2a equals 10. So I divide by 2, and I get a equals 5. Fantastic. Okay, so I got my first value, my polynomial, where I know the a value, the leading coefficient, was 5. And I can take that and sub it in here, which is going to be 18 minus 4 times 5 is equal to b. And so 4 times 5 is 20. So therefore, 18 minus 20 is negative 2. So now I know b is negative 2. And now it's much simpler just because it happened to work out this way. This system turned out not to be so bad. I can now take my a, sub it in there, take my b, sub it in there. And we're going to say, what are we looking at here? 17 equals 4 times 5. Yep, just had to make sure I had the right number. B is negative 2 and C. So now, here we go, solving for C. So this is going to be 17 is equal to 20. 2 times negative 2 is negative 4 plus C. So 17 is equal to 20 minus 4 is 16. Subtract 16 from both sides, leaving me with C is equal to 1. And the most common goofy thing we can do is be like, I'm done. No, what? Always go back to the very beginning of the problem and make sure you answer the question that was being asked. What do they ask us to find? A second degree polynomial. I know the a, the b, and the c, but I have not written it down. So now, what would my second degree polynomial be? The a value was 5. The b value was, well, it's negative 2, so I'll put a minus there, minus 2x, and the c value was 1. There we go. Now, how can I verify that I got it right? I'm going to take a moment and just type this in here into Desmos. And I apologize, I'm going to fix something. I can't believe I wrote C here instead of 1. So let's fix that really fast. So it should be 1. Okay, so now I type that function into Desmos, as you can see here. And now to make sure I did it right, what I'm going to do is say, well, what were the values I was supposed to have? Well, the first value I was supposed to have was when I sub in 2, I get out 17. So if I type in P of 2, it gives me 17. Perfect. Then what was the next thing I was supposed to have? Well, I'll go over here and say, no, P prime. All right, so P prime of 2. Whoops. Sorry, we're doing this virtually here. There you go. When I subbed in P prime of 2, that was supposed to give me 18. The blue is checking out. And now we go check the green highlight. What is the last piece of information? Make sure I got this right. P double prime of 2 was supposed to be equal 10. Perfect. I know I got it right. The polynomial that I wrote meets the 3 characteristics that were prescribed. So therefore, even if there is some other solution, which there isn't, I know this one is valid. All right, moving back. For this problem, all right, so for this problem, we're going to go ahead and we need to pay attention to what is the problem asking us to find. Always start with that, right? And it's saying they want the equations of both lines through the point 2, negative 3 that are tangent to this parabola. Okay, first keyword, both lines. All right, so we're not writing the equation of one line, we're writing the equation of 2 lines. Now, what do we need to write the equation of any line? Well, we always jump to point slope, so it's y minus y1 is equal to slope of the tangent line times x minus x1. So I need an ordered pair that my line is going to pass through. All right, we already have one of those. And I need the slope of the tangent line. Now, what are we supposed to be tangent to? Well, we're supposed to be tangent to this parabola. So therefore, by definition, we know the slope of the tangent line is the derivative. So that would be 2x plus 1. So I know whatever my slope of my tangent line is, it's going to come from this equation. I'm going to plug in the x value, and I'm going to get out the slope, right? The slope that I need for my equation, my line. And I'm expecting to have two slopes. Okay, so let's go take a peek at this graph to kind of see what's going on. So you can imagine, all right, our graph would look something like this. I've just screenshotted from Desmos. And you can imagine there'd be two lines, maybe one line that it's got to go through the point 2, -3, and it's got to be tangent. So maybe one line is going to kind of do something like this. And then the second line, if our parabola continued, you can imagine, well, it wouldn't be that, whatever, but it would come up and kind of catch it up there. So we're going to have two tangent lines that are going through 2, -3. And clearly, the points where they are tangent, wherever that tangent would be, whatever that number is, would be two different x values. One of our x values is going to be, somewhere here, looks like to me around -1. The other x value, I have no idea because I don't know. Like, that's just not pretty. But we just know it's not going to be -1. So let's go back over here and see if we can figure out what we're doing. Now, the first thing I'm going to do is, well, I'm going to sub in what I know, right? The very first thing I'm going to do is say, I know that my y value is -3, so that's +3. And then my slope of my tangent line would be x minus 2. All right, perfect. All right, got my order pair subbed in. Now, I know my slope of my tangent line has to follow 2x plus 1. So let's sub that into, let's say, 2x plus 1, x minus 2, right? So this will be the equation of the line, right, that is going to pass through the point 2, -3, and will have a slope that is the same as the slope of my tangent line, because that's what I subbed in, right? So I need the right x values. I need to know what x value will make that occur. So the last piece of this is, notice we haven't used the graph of the parabola to get the x and the y values. So I know whatever the y value is, where this second point is going to occur, has to be where x squared plus x, the value of x squared plus x. So if I sub that in for y, x squared plus x plus 3, right, subbing that in for y, is equal to 2x plus 1 times x minus 2, right? So do you see, we just took the equation of our line and we have subbed in the slope. We subbed in the equation we want it to the other point to be on, which is the parabola, and we subbed in their ordered pair. So given all of this, we should now hopefully be able to solve this. Let's see what we're looking at here. So this left-hand side, I'm going to leave as x squared plus x plus 3. This right-hand side, I'm going to do a little bit of distribution or FOIL, whatever you've learned and whatever you like. So that's going to be what? 2x squared minus 4x plus x minus 2. All right, so let's combine some like terms. This is just an algebra step. So we're going to be left with x squared plus x plus 3, 2x squared. Let's see, -4x plus x. That make -3x minus 2. All right, now this is a quadratic. I've got x squareds and x's, so we always want to get those equal to 0, so we can solve by factoring, hopefully. So we're going to subtract x squared, subtract x squared. We're going to subtract x, subtract 3, resulting in, let's see, 0 is equal to 2x squared minus x squared is x squared, minus 4x minus 5. And look, we already said we know there's going to be two equations, or we believe there to be two equations of that are going to be tangent that go through that point. We have a quadratic, two different values to solve. So let's see what we can do here. Let's see if this factors. Please be easy. What times what makes -5 adds together to make -4? Well, that looks to me like -5 plus 1, because -5 times 1 is -5, check. And -5 plus, so that'd be -5. -5 plus 1 is -4, check. We're good to go. Okay. Well, really, it would be like this. It'd be like this. This would be -5x. Sorry, I was just a little shorthanding because we're in calculus. But long story short, -5 x plus x makes -4x. So perfect, check, check. All right, factored. So therefore, we have the x value of 5 and the x value of -1. And if you remember, it kind of, just by our little freehand, it kind of looked like our tangent line was going to hit somewhere around -1. And it looks like it's hitting around -1. Perfect. Now, whenever you're done, right, whenever you think you've solved a problem, always go back and read and say, did I answer the question that was being asked? What was the question being asked? Find the equations of both lines. We didn't find the equation of a line yet. All we did is found the x value where it would be tangent. So what do I need to write the equation of any line? I need a point and a slope. What I just found is the x values of the tangent lines, right? So therefore, I want to find what is the slope at 5. So I'm going to go ahead and take my slope of my tangent line, plug in 5. So that's going to give me 2 times 5 plus 1. So therefore, the slope at 5 would be what? 2 times 5 is 10. 10 plus 1 is 11. So my slope at 5 is 11. And then I need my slope at -1. So if I sub in -1 into my slope, so that's 2 times -1 plus 1. So therefore, my slope at -1 would be what? -2 times 1, or -1 times 2 is -2 plus 1. So that'd be -1. So now I have everything I need to write the equation of my line, because I have the point that we're going to pass through, which was 2, -3. So y minus a -3 is equal to, and then I need my x value for 5, which was the slope of 11, and x minus x1, which would be 2. There's one equation. There's one for the x value of 5. Then I need my other one. So y plus, it's still going through the same point, right? What was the slope for the x value of -1? Well, that slope was -1, so we're going to sub in -1 times x minus 2. So now we have two equations that describe a tangent line that is tangent to the curve at these particular x values. One of the x values is -1, the other x value is 5, right? So we are tangent at both of those x values, and they also pass through the point -3, 2, right? Because that's built into the equation of our line. And we can verify this. Of course. Let's go ahead and pop this into Desmos and see what we see. All right, and so you can see I have gone ahead and typed in our two equations that we found, and you can see there it is, the black line going through our point to -3, and we can see there we go, it's intersecting at -1, 0, and this one at the value of 5, it's a little tough to get out there, but there you go. You can see it's intersecting at 530. It has its tangent line at 530. We wrote two equations of lines that are tangent to our parabola and passing through the point to -3. Fantastic. All right, now the next question, I'm not even going to go from the screen. I'm going to stay here for a minute. The next question here is saying the exact same parabola, but we're going to look at the point 2, 7, and we're going to say, okay, I want to write the equation of the lines, or all the lines, or not, whatever, that go through the point 2, 7 and is tangent to our parabola. So if you're looking at this point saying, how am I going to draw a tangent line? Hopefully we recognize there's nothing in here is going to be tangent, right? Because it has to touch at only that one place and kind of glance off. And we could touch, but we'd pass through. We wouldn't glance off. We wouldn't have that tangent line look. So we got to keep looking. Nothing on the inside here, nothing here, nothing here, right? These are all going to just kind of intersect with our graph. So if you imagine, will we ever be able to find a point where we would be tangent? And the answer is, I'm kind of looking at this graphically and saying, I don't think so, because we're coming from the inside. So if we're coming from the outside, we're able to take advantage of that curve of the graph to kind of bounce off of it. But coming from the inside, I don't think it's going to happen. So my gut tells me there are no tangent lines. My gut tells me this is impossible to do. Okay. And let's see here. The directions are saying show that there is no line through the point 27 that is tangent to the parabola. So my gut matches the directions. That's a good sign. All right. So but that's not a good mathematical argument. Let's go ahead and show this algebraically. So how do we do that? We need to, I don't know, do the exact same thing we just did. I need to write the equation of a line. This is what they're asking me to do. Write the equation of a line passing through 7, 2. There we go. And that is tangent to our parabola. Well, we already know the derivative was, what was the derivative? 2x plus 1. So that's the slope of my tangent line. So we're going to say this is y minus 7 is equal to 2x plus 1 times x minus 2. And I want to find the y values that make this work, or the x values that make this work. So I need to substitute my y with some x's. So that's substitution step, x squared plus x. So we're going to go ahead and say this is x squared plus x minus 7 is equal to, and just because we know what's coming, let's go ahead and distribute this. So this would be 2x squared minus 4x. It's the same. Oh, it's a different point. So actually, may not be the exact same math. Let's see. So this would be plus x minus 2. And this parenthesis here isn't doing anything for us. So we know algebraically, we've got a quadratic. We want to get this thing equal to 0. So we're going to subtract everything to the other side. So I'm going to subtract x squared, subtract x, and of course, last but not least, add 7, resulting in 0 is equal to x squared minus 5x. It helps if I combine my like terms. Let's go over here. Let's add 7 over here. All right, and let's see here. That actually works out kind of nice because the plus x and the minus x simplify. So that's just going to leave me with negative 4x. That's a little better. And then negative 2 plus 7 would make positive 5. Okay, seems very familiar to the last problem. Okay, let's just see here. What times what makes positive 5 and adds together to make negative 4? Well, multiplying to make a positive either means they need to be both negative or both positive. And because we need them to add together to make negative 4, they would have to be both negative. And what times what makes 5? Well, there's only one option, 1 and 5. And that does not add together to make negative 4. That would make negative 6. So this isn't going to factor. So immediately, I mean, you could complete the square, but me personally, I'm going to jump to quadratic where a is equal to 1, b is equal to negative 4, c is equal to 5. Here we go. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I'm seeing it. I'm looking a step ahead. Maybe you're seeing it too. We're expecting no solutions. And I'm watching underneath this radical. 4, that's going to be 16, right? 4 squared is 16. Negative 4 times negative 4 is positive 16. And then under here we have 4 times 1 times 5. That's 20 all over 2. And what are we seeing here under this radical? 16 minus 20. That's going to be negative 4 over 2. And we know under a radical means we have no real solutions. And in calculus, we're only caring, in Calc 1, we're only caring about the reals, right? In your electrical engineering courses, the imaginaries become very important, right? But for right now, we're going to say no real solutions. So therefore, what does that mean as far as the lines that are tangent to the curve that pass through that point? That means there are no tangent lines or no solutions. Okay, all right, so hopefully that makes sense. What is the big idea? What is the big takeaway? Go ahead and recap that for yourself. You're going to say, okay, if we're trying to write the equation of a tangent line, we always start the problems the same way. Y minus y1 is equal to our slope times x minus x1. If we know the slope, the point where we're tangent to, we start off by just plugging in that x value into our slope. But if we don't know the point, that's okay. We can take our equation of our tangent, the derivative, the equation of the slopes, there we go, and just plug that in, right? Just how it looks. And then now we're in a solving. We're in a mode of, okay, I now need to also know, I got to get this y value out of here. I got to have, what graph am I trying to pass through? Well, we are trying to pass through y equals x squared plus x. So I sub that in. And then I'm now able to solve for x. And here's the big piece. Don't forget what these x's are being used to do. Don't forget what these represent. These are the x values on your curve. These are the x values on your parabola where your graph is tangent. Okay, and so therefore you then use these x values to find the slopes, that you can then use to write the equations of your tangent lines. All right, hope this helps. We'll see you in the next video.